Hi, my name is Christof, and I'm trying to get some light into the black box of what is machine learning.
Hi, welcome to Dubai. That is what you might think of: big shopping malls, artificial aquariums or artificial islands. But there's more. Yes, there's also this big waterfall, but I don't mean this one. No, it's also not the famous ice ring in Dubai Mall. I want to talk about something different.
I said there is more, and actually there's a lot more about artificial intelligence and machine learning within Dubai. Did you know that Dubai is one of the first countries that has an agenda for artificial intelligence and a dedicated strategy to integrate it into government services, to improve transportation, healthcare and security, and of course to save billions of dollars? And Dubai is also probably the first city that has a special theme song composed by machine learning algorithms. The hymn has been composed by an artificial intelligence virtual artist called Aiva. The underlying machine learning model has been trained with 30,000 music scores composed by Mozart, Beethoven, Chopin, Vivaldi and other classic and contemporary composers. And actually in some parts it sounds a lot like Freude schöner Götterfunken or Ode of Joy from Beethoven. So Dubai is a good place and a good background to talk about our topic today. In the previous video we looked into face detection. Let's go one step further and talk about face recognition. I'm now using the Face Tracker app, where the credit goes to Gene Kogan and his incredible work in machine learning for artists on GitHub. This one is also based on Andreas Revgaard's work for the Eye Conductor project. This Face Tracker app is using face detection and some pre-trained machine learning models to detect the features of my face: the eyes, eyebrows, nose, face line and jawline. But what does it mean, pre-trained model? Let's use another version of this app to do some training on our own. I now want to train our app to recognize different face expressions, like a surprise face, or a happy face. And I start with providing a set of examples for each category. I start with a category number 1 and record first some examples of a normal face expression. And I stop the recording and I have 245 samples now recorded for the first category. I change to category 2 and I want to record a surprise face. Stop the recording, and last category number 3, let's record a big O. Okay, now we have set of examples recorded for each category, and I switch to the training mode and want to check how the prediction is working. So now we have class number 1. That should be the normal face. Let's try the surprise one. It's going to class number 2 and class number 3, the big O. Oh, it's working. We now trained a machine learning model. Let's summarize it. In the Face Tracker app, we used a pre-trained machine learning model. This model has been trained with several other faces to identify the right eye, the left eye, the jawline, and so on. When I use my face as an input for the model, which for sure the model has never seen before, it can identify the features of my face. The app is just using the output of the model to draw the additional screen lines. In the next step, we trained a new model using the output of the first one. First, we recorded some input pictures and gave it just a category number. We did this for 3 different categories. This already includes step 1 to 4 of the classical machine learning steps. Number 1, define your problem. So we wanted just to identify different facial expressions like a happy face or a sad face. Number 2, collect and prepare your data. We are using the input of our webcam to collect the input data. Number 3, select the relevant features. We are starting based on a pre-trained model that identifies the features of a face. Number 4, choose your machine learning algorithm. Simply speaking, we are using a machine learning classifier. In the next step, we trained the model and could see the prediction of the facial expressions. The app we are using is built in a way that we are covering step 5 to 8. Number 5, our input data is split in training and evaluation data. Number 6, the training data is used to train the model. Number 7, the evaluation data is used to minimize the prediction errors. And finally, number 8, the model is applied to show the prediction class of the new incoming data we are making live in front of the camera. We now learned and already applied the basic steps of machine learning. But why are we doing this? Why do we need these 8 steps? Imagine you want to try to solve this problem with classical programming. Maybe you would have started to create some code to detect the facial features. Even if you manage to do so in a reasonable time, which is most unlikely, you start to do the same with a new problem to recognize a facial expression. Machine learning models have the advantage that you can use them for many different problems without starting new extensive programming. To solve our problem of recognizing facial expressions, we basically used, on a high level, the same approach or model that solved the problem of recognizing a nose or the eyes or the mouth. The same can be used to classify any type of pictures. It doesn't matter if you want to classify the pictures of a product catalog or some handwritten pictures.
Okay guys, I hope you enjoyed our today's tutorial and hope you see you soon on this channel, and don't forget to leave the messages down below. And then, yeah, see you next time. Stay tuned. Bye.